One of the major issues facing the world today is energy. And the fact is, there may not be enough energy to support our future needs. According to the Global E-Sustainability Initiative, data centers represent about 18% of the ICT greenhouse gas emissions.
Data centers are energy hogs. A typical data center uses somewhere between 30 and 80 times the amount of energy per square foot or per square meter as a traditional office building.
2 to 5% of the electrical consumption in the U.S. is now inside of data centers, and honestly I think it's larger than that because they're only sampling the data centers themselves, not the server rooms and labs and everything else that runs companies.
The United Nations estimates that the use of energy around the world will increase by about 50% by 2030. If this increase in energy use in data centers, this doubling every 5 years continues, then that 2% use today by data centers around the world will become 12% of the total energy in the planet by 2030.
The data center of the future will be a warmer place. It will be a place where it's less made really to pamper the IT equipment, but to focus much more on functionality and on efficiency and flexibility.
If you notice the temperature in here, it's 74 degrees Fahrenheit. So we can run it warmer because we're containing the heat. And every degree that you increase that temperature Fahrenheit-wise is a 4% efficiency gain all the way through to the plants. So this data center, as we were saying, is the highest density in here. Let's take a look inside one of the hot aisles and you'll get an idea. 74 degrees Fahrenheit outside, 95 to 105 degrees inside. So as you can tell, inside of this room is actually pretty warm, right? 95 to 105. And you feel behind these servers, you can feel the temperature. Right? It comes out. So 74 degrees inlet, and then it rises up because the component's heated up, and then it comes into this contained hot aisle. If you now go over to this one, if you feel the temperature in this coming out, so because it's colder, there's a cool threads technology, right? This is older generation equipment, and if you notice, it's a mixture of everything in here. We don't care, because whatever work has to be done, we can still make the environment very efficient. But this is next generation technology that allows you to now run the systems with a higher inlet temperature, and it's still not very hot in here. Yes. So cool threads basically does the same work with less heat being generated. Just so you get an idea of this room, this cut our power bill in half. So significant cost reductions when you really go back and say, how can I build my data center to be really efficient?
Building data centers is expensive, but even changing power supplies into individual racks can have a price ticket of as high as $25,000.
This is a 50 amp three-phase outlet, but now just think of it, it's just a module that I go into the busway and snap in. So literally in minutes, I can have the power where I need it to go. The other beauty of this is it's not just one type of outlet. I can have a 60 amp three-phase or a 50 amp three-phase right next to a 110 outlet. Now, if you think about this from a sustainability standpoint, usually what happens when people are deploying hardware, they're going to call the electrician and they'll run all that copper to get this kind of connector to the right location. And then they leave it in place because the risk of an outage is too great. Now what you have is I'm using less copper, literally up to 75% less copper, and I'm reusing these outlets for the life of the data center.
Power consumption in data centers is very high. There's several reasons for that. I think the most important reason is the way that these devices are powered. They're powered with AC power, and that AC power is then converted into DC power in each individual server. And that conversion process is very inefficient. They typically lose 16 to 17% of the energy in that context. So already you only 84% of the power reaches the actual server. And that is why led by NTT Labs, people are now considering a new standard, a high voltage DC standard to power servers from DC sources to eliminate that conversion process. And automatically, what comes with that is that gain in efficiency of probably 14 to 15%.
We've done some analysis that says if you went to a pure DC environment, your total energy consumption would drop by about 11%. So there is that potential savings. On the other hand, if you look at a high voltage AC environment, the potential savings is about 9% versus the environments that people are currently in. And there's a series of trade-offs for both of these environments. The high voltage AC environment, quite frankly, could be turned on today. It's available in all geographies, and the IT equipment is compatible to high voltage AC environments today. The DC environment challenges are not all technologies are available in a pure DC environment. So the client would have to choose which technologies and potentially pay a premium or not a premium for that subset of technologies that are available in that environment.
Energy shortage is also driving the use of alternate and renewable energy, and efficient energy practices will become key.
So we're seeing two trends. One is the location of clients locating near power generation facilities so they don't lose that transmission loss. The second is an emergence of something we call cogeneration, where clients are producing their own energy.
We have achieved that our major campus, the Round Rock Austin campus, is 100% on green energy, which is wind turbine energy and methane gas from landfills.
The savings aren't necessarily associated with the cost for the client, but they are huge savings associated with environmental savings from transmission loss, because you're generating right at your location what you need. You're not losing the 60 to 70% from that coal-fired energy generation plant or from that hydroelectric plant or that nuclear energy plant.
One of the most important things is that the companies start thinking about the total costs of these facilities. Right now you have split incentives. You have different parts of the organization are responsible for the data center. So the IT department is responsible for buying the computers. The facilities department is responsible for paying the electric bill. So the IT department doesn't have any incentive to spend even an additional dollar on an efficient power supply, say, because the savings don't accrue in their budget.
What we found at Forrester, working with our clients, is that it's often a third party within these large companies that has to get involved, namely the finance organization. They often have the key to unlock the silos, to blend CapEx and OpEx, to blend the costs of more energy efficiency with the benefits of more energy efficiency.
We did a hardware replacement program within our consolidation of the data centers, and real estate bought the hardware for IT and engineering because we got the utility gains, the savings. We also got the tax savings and the maintenance savings, because it's one big bucket, the second largest expense of the company, that my boss pays. So it's a completely different way to look at the problem. The IT and engineering sides are very happy because they're getting refreshed equipment. And the real estate side is very happy because they're lowering their actual utility bill. So it's a great balance between the two.
People and institutions need to be changed in order for us to become more efficient in the way that we design and build IT equipment.